In this video, we will be solving triangles. Triangles that are not right triangles, just normal oblique triangles. And we will be using the law of sines. This is the law of sines. First of all, notice the notation that we use, the convention that we use. We use capital letters for the angles, lowercase letters for the sides, and the opposite, the side that is across from an angle is going to correspond to that angle. So capital A, lowercase a, they're across from each other. Capital angle B is going to be across from lowercase side B. And you know, these capital C and little c look very much the same, but still, they're across from each other. Keeping that in mind, we will not necessarily need a picture to know what's going on. So when I say sine A over A, you know that I'm talking about the sine of an angle divided by its opposite side. That should be equal no matter what angle side pair you pick. All of those ratios should be equal. So let's use that fact to solve some triangles. Oh, by the way, solving a triangle means finding any missing angles or sides. Now we are not given a sketch, so I am just going to draw a temporary sketch of triangle A, B, C. So we know that angle A is 25 degrees and angle B is 35 degrees. And we know that side B is 12, which goes right here across from angle B. We do not know side C, and we do not know angle A. And we don't know angle C for that matter. So those are the three things we must find. The measure of angle C, got to find that. And we need to find the length of side A and the length of side C. So this is our goal. So how are we going to do that? We're going to do the law of sines. So the one pair that we definitely have is this pair right here. We have the angle and the opposite side. So no matter what, we're definitely going to use this. So we could say, all right, the sine of angle B divided by the length of side B should equal the same ratio for any other angle side pair. So we have angle A over here, so we could use the ratio to find side A. So I would go like this. I'd say the sine of angle A, which is 25 degrees, over side A. Okay? I can solve this for A. I can do that by cross multiplying. If I do this diagonal, then I'm going to have A sine 35 is equal to 12 sine 25. Alright, then to get A by itself, I would have to divide both sides by sine 35. So these will cancel out, and that will just leave A by itself. So I can just put all of this in my calculator. Let's see, 12 sine 25. Alright, if I hit alpha y equals and enter, I get a fraction. Now 12 sine 25 over sine 35. Now, right here at the beginning, I need to check and make sure I am in degree mode, which I am. So here I go. I'm getting 8.842, got to round up. Okay, so that is the length of A. We can go ahead and find angle C very easily. The total degrees in a triangle always have to add up to 180. So the measure of angle C should equal 180 minus the other two angles. So minus 35 minus 25. So you could just put that in your calculator and see what you get. Alright, that turns out to be 120 degrees. So that just leaves side C. Well, now that we know that this is 120 degrees, it should be easy to find side C. All I have to do is I will use the same ratio that I used before. Okay, I will use sine 35 over 12. Now that should equal, and I'm going to make this ratio right here, sine of 120 over C. But this is kind of in my way though. Alright, so that should equal the sine of 120 over C. And again, I can solve this just like I did before. So along this diagonal, I will have C sine 35, and along this diagonal, I will have 12 sine 120. And then I will divide both sides by sine 35. So these will cancel each other out. And I will just put all this in my calculator, but I'm going to do that off camera this time. And I got 18.118. Now, I know it says round to the nearest tenth, so this would be 8.8 and this would be 18.1. In general, we use 3 decimal places in case we need to use these values to find something else. So that's why I'm ignoring the directions and using 3 decimal places. If you ever need to use a value that you just found to find something else, 1 decimal place will not be enough. You have to use at least 3, if not more. So I'm really gonna ignore this and just use 3 decimal places, and you can easily tell what the answer would be if you really rounded to the nearest tenth. Anyway, let's keep going. So here we go again. I have 2 angles and a side. So I can tell that I am missing angle C. So that's something I'm going to need to find. Alright, we're going to need to find the measure of angle C. And we have this side, but we're missing side A. Going to need to find that. And we are missing side B. So these are the 3 things that we need to find. Okay, I'm just going to draw a temporary picture over here that I can refer back to. Okay, so here's angle A, B, and C. Angle A is 65 degrees. Angle B is 50. And side C is 12. So that will go right here across from angle C. So, you know what? Let's go ahead and find angle C right now. These have to add up to 180, so I'm just going to take 180 minus 65 minus 50. And that is 65. So that tells me that angle C is 65 degrees. Well, interestingly, because this is an isosceles triangle, just by coincidence, that tells me that this is going to be 12. But I feel like I should use the law of sines, because maybe you wouldn't have noticed that, so I'm going to pretend like I don't know that. But if I were just doing this for fun, I would recognize that these are base angles of an isosceles triangle. Therefore, the sides across from them will be equal. So anyway, we have just found angle C, so I'm going to go ahead and fill that in. So angle C is 65 degrees. All right, let's go ahead and find side A now. But let's start with the one pair that we have. We have this side across from this angle. So we definitely want to use that. Just put a little line right here. So we definitely want to use the fact that sine of 65 over 12. Alright, the sine of the angle divided by the opposite side. That should be the same for any other pair. Okay, so for example, if I want to find side A, then that's this pair. So I will say sine of 65 over A. Okay, and you know what, I just cannot continue with this farce. I'm not going to sit here and cross multiply. We have sine 65 over 12. We have sine 65 over A. Obviously A is equal to 12, like I was saying before. So it would be silly to go on any further. A is obviously 12. Okay, let's move on to finding side B. Alright, so this would be side B down here. Okay, that's across from the 50-degree angle. So we will use the same setup as before. Sine 65 over 12 should equal sine of 50 over B. So here we will cross multiply to find this. So along this diagonal I have B sine 65. Along this diagonal I have 12 sine 50. To get B by itself I need to divide both sides by sine 65. So the sine 65s cancel out. That leaves B by itself. So I will just put this in my calculator and that'll be the answer. I'm going to do that off camera. And I'm coming up with 10.143. And so that's it for problem number 2. We have solved the triangle. Okay, let's see. What are we missing? We have these two angles, but we do not have the measure of angle A. So we're going to need that. We have side A, but we don't have side B or side C. So those are things that we're going to need. Here is a temporary sketch. Alright, A, B, and C. B is 24.8. C is 61.3. And side A is 8.2. Okay, first things first, let's find the third angle by subtracting these two from 180. I'm going to do that off camera. That turned out to be 93.9. Now, doing the law of sines, we're going to need these opposites. Okay, this angle and this side are opposite from each other. So we will need this ratio, the sine of 93.9 over 8.2. Alright, and that should equal a similar ratio for the other angles. Okay, so next I think I will go ahead and try to find side B. So angle B is across from side B, of course. So the sine of 24.8 over B should be equal to this. So I'm just going to solve this by cross multiplying. Along this diagonal I have B sine 93.9. Along this diagonal, I have 8.2 sine 24.8. In order to get b by itself, I need to divide both sides by sine of 93.9. Alright, so these will cancel out, leaving b by itself. So I'm just going to put all of this into my calculator. I got b is equal to 3.447. Okay, let's do that one more time to find side C, which of course will be over here. Okay, so we're looking at angle C, which is across from side C. So actually, the first thing I'm going to do is use the same ratio I used last time, which is the sine of 93.9 over the 8.2. Alright, the yellow pair that we started off with. And now I will say the sine of 61.3 over C. So these should be equal. By cross multiplying, I'm going to get C sine 93.9 should equal 8.2 sine 61.3. But then I must divide to get C by itself. I need to divide both sides by the sine of 93.9. Okay, so these will cancel out. So now C is by itself. I'm just going to put all this in my calculator off camera. I got 7.209. And that's it. We have solved the triangle. Okay, I'm going to do one more in this video. Let's do number 4. Okay, same type of thing. Let's see, we have angle A, we have angle C. We are missing angle B, so we're going to need the measure of angle B. And we have side C, but we don't have side A. And we do not have side B. So we're going to need these three things. Here is a temporary triangle. So, triangle A, B, C. A is 39.25. Angle C is 64.75. And angle B is unknown. Side C, which will be across from angle C, is 19.3. Let's go ahead and find angle B by subtracting these two angles from 180. I got 76 degrees. Now, let's use the law of sines. Let's start out with the one angle side pair that we have. Alright, we have this angle and the side that is across from it. So we're definitely going to use that information. So we will do the sine of this angle. So the sine of 64.75 over the opposite side, 19.3. That should equal the same ratio for another angle and side. Let's see. So let's find side A next. So here would be side A over here. Okay, so I want to find side A, so I will need the angle that's across from it. So we will have the sine of 39.25 over A. Now I'm going to cross multiply. So along this diagonal, I have A sine 64.75. Along this diagonal, I have 19.3 sine 39.25. And then I need to divide both sides by sine 64.75 in order to get A by itself. So these will cancel out and I'll have A by itself. I'm going to put this in the calculator off camera. I got 13.501. Alright, so that just leaves side B, which will be right here. Okay, so if I want to find side B, I'm going to have to use the angle that's across from side B. Now I'm going to start by using the same ratio that I used before. So I'm going to start by saying sine 64.75 over 19.3, just like before, is equal to, but this time I'm going to do the sine of 76 over B. And then I will cross multiply as I did before. So this will be B sine 64.75 is equal to 19.3 sine 76. I will have to divide both sides by sine 64.75 to get B by itself. These will cancel each other out, and that will leave B by itself. So I'm just going to put all of this in my calculator off camera. And I'm getting 20.705. And that is it. We have solved the triangle. I think I said that number 4 would be the last problem on this video, but actually it's going to be number 5, because this is one more problem that's really, it looked different at first, but it's really the same thing. So we're not solving the entire triangle is the only difference. This time we're simply finding the length of side B, and that's it. So here is our little sketch, little diagram. Alright, so triangle A, B, C. 37.33. Angle B is 51.5. We don't know angle C, but side C is 125. Side C goes across from angle C, so I will put the 125 right here. Okay, because we have the 125, we really need the angle that goes across from it. We need angle C. So we are going to take 180 and we're going to subtract these two angles. We're going to subtract 51.5 and we're going to subtract 37.33, and that should give us angle C, which we need. Well, that turned out to be 91.17. So now we have an angle and the opposite side. So we are ready to do the law of sines. So according to the law of sines, I can set up a fraction, a ratio, using the sine of 91.17 over 125, the opposite side. And that should be the same for other pairs of angles and opposite sides. So we're supposed to find the length of side B. side B is over here across from angle B. So let me just highlight to make sure you understand what we're talking about. Alright, so here's angle B and here's side B. So that's going to form the next ratio. So alright, all of this should equal the sine of 51.5 over B. So a little cross multiplication. Along this diagonal I will have B sine 91.17. Along this diagonal I have 125 sine 51.5. If I want to get B by itself, I need to divide. I need to divide both sides by the sine of 91.17. These will cancel each other out, leaving B all by itself. I'm just going to put all of this in my calculator, and I'm going to do that off camera. I am getting 97.846. And that's the answer number 5. Okay, that's going to do it for this video. I hope it was helpful, and I will see you on the next video.